Section 2 in Chapter 7 is very closely related to Section 1. We're looking at exponential functions a little bit more and some more properties related to them. So in Section 1, we learned how to graph an exponential function, just very basic. Now in Section 2, we're looking at some transformations. And our first example here, we're going to graph y equals -1/2 times 5 to the x power. So hopefully you can kind of notice here that we really have 5 to the x power as our parent function, if you will, and then we have transformations from there. So we have this negative out front that would reflect over the x-axis, and that 1/2 is really a vertical compression. So I'm just going to make the note here that this is a transformation of y equals 5 to the x power. Knowing that will make graphing this function a lot easier. So let's start off by making a table of that parent function, y equals 5 to the x, and then we'll transform our table from there. Anytime we have an exponential function that we're trying to graph, we want to use these x values, -2, -1, 0, 1, and 2. And then if we have 5 to the -2nd power, that really means 1 over 5 squared, or 1 over 25. 5 to the -1st power is 1 over 5. 5 to the 0 power is 1. 5 to the 1st, 5 to the 2nd. And then, like I said, we have these transformations coming. This negative reflects over the x-axis again. That 1/2 is a vertical compression. So I need to take each of my y values times -1/2. Okay, so from here, to take a fraction times another fraction, remember that we multiplied the numerators and we multiplied the denominators. So we would get -1 over 50, -1 over 10. This is -1/2. Okay, keep in mind that the 5 here is really 5 over 1. So make this 5 over 1. My numerators multiplied. It's -5 over my denominators, 2. And then same idea here, 25 over 1. Multiply your numerators and your denominators. You get -25 over 2. Now to graph this, keep in mind that these fractions, -1 over 50 and -1/10, they're pretty small. So -1 over 50 especially is just going to be really, really close to the x-axis. -1/10 is pretty close to the x-axis as well. When we get over to the -5/2, as far as graphing purposes go, it might help to think of this as -2.5 and to think of this as -12.5. We like fractions, but as far as graphing goes, it's a little easier to figure out where those should go if we think of decimals. So -2, -1/50, like I said, it's right off of the x-axis. -1, -1/10, it's pretty darn close to the x-axis as well. Then 0, -1/2, 1, -2.5, and then 2, -12.5 is going to go off my graph. So I'll just connect these dots. And keep in mind that we still will never cross the x-axis here. We want to make sure that our graph is not crossing the x-axis because we'll never have a value for x that would give us a positive y value. Okay, so here's what our graph looks like. Hopefully you can see that we have that reflection and our exponential function is still changing very rapidly. Our y values are just decreasing now very rapidly. So our asymptote still has not changed. Our asymptote is still on that x-axis here, y equals 0.